Hello, 6th grade. Today I want to do some problems along with you on page 395 in your book. So if you could open up, these are all word problems involving area, and I think that it would be helpful if we worked on them together. So I will let you use a calculator on these problems. So if you have one handy, go ahead and get it out also. All right, so we're starting with problem number 6. Alice wants to put wall-to-wall carpeting in a small room with the floor plan shown, which is what is over here on the right-hand side of your paper. See that? And a floor plan is sort of like a tops-down view of the shape of a room. So you can see this has 1, 2, 3, 4, 5, 6 walls to it, which makes it a hexagon. And wall-to-wall carpet means from one wall to the next, the whole entire floor would be covered with carpet. So Alice says she can find the area of the room by dividing the floor plan into 2 trapezoids. Show how she can divide the floor plan and then find the area using her method. So right now, if you look, you probably would think of this as 2 rectangles, but she wants to look at it as 2 trapezoids. So in order for this to be divided into 2 trapezoids, we're going to create this diagonal right here. Okay, so now you can see that we have trapezoid number 1 and trapezoid number 2. I apologize, there seems to be a little bit of a delay with my document camera here. So we did part 1. We showed how she could divide the floor plan up into 2 trapezoids. Now we need to find the area. So if you remember the area of a trapezoid, the formula is that you take half of the height times the sum of the 2 bases. So if we look at trapezoid number 1, the area would be equal to half of the height, which in this case would be 5 feet. And the sum of the bases would be this 7.5 and 15.5, which would be 22.5. Okay, now the second one, I can just add to this now, the second trapezoid, which would be half of the height. Now in this case, the height is 7.5 feet because the 2 parallel bases are 5 and 10. So 7.5 is the height. The sum of the 2 bases would be 5 and 10, which is 15. And so now we would just follow the order of operations. So if you're using a calculator, I'm actually going to put the calculator here. Let's see, that's not a calculator. Hold on. That's a calculator. All right, so now we have half of the product of 5 and 22.5. So if you do 22.5 times 5 equals, and then divided by 2, you get 56.25. And I'm just going to go ahead and record that on my paper. That would be the area of the first trapezoid. And we need to add to that the area of the second trapezoid. So I'm going to clear my calculator. And now we have half of 7.5 times 15. So I'm going to do 15 times 7.5 first. I can do that because of the commutative property. And then I'm going to divide it by 2 because that's what taking half means. And if you see that we got the same result, 56.25. So now we're going to add those 2 together, and we get 112 and 5/10. So now let's think about that, what that means. I'm switching back to the paper. We're trying to find the area of this room. The sum of the two trapezoids is 112. I'm going to write it up here. The area is equal to 112 and 5/10. And then really important that we have the correct unit of measure, which in this case we're measuring in feet, and area is always a squared measurement, so we would include an exponent of 2 because we're squared feet. Okay? Now the second part of this asks you to find the area using another method. So this time I wish I could do this. I think I'll do this on a piece of paper now. I'm just going to quickly draw this. So this is 10 feet. This is 7.5 feet. This is 5 feet. 7.5 feet, 5 feet, and 15 feet. The question was, could we have done this a different way? And we sort of mentioned that at the beginning, is that we could have drawn two rectangles, and we could draw it either this way, or we could have drawn it this way. So let's just go with the first method. So this would be rectangle 1 and this would be rectangle 2. So the dimensions of rectangle 1, well, we know first of all that we need to do base times height because these are parallelograms. Right? A rectangle is a parallelogram. So the base of 7.5 feet and the height is, what's the height? I have to look over here to see that the height is 5. So it would be 7.5 times 5 for the first one. The second one would be a base of 15 and a height of 5. And so now we could do that calculation. 7.5 times 5 is 37.5, plus 15 times 5 is 75, and if we add those two values, we get 112 and 5/10. And again, this is a unit of measure. The unit of measure is super important here, 112 and 5/10 square feet, because we're talking about area. So there we've got the same answer, breaking it up as trapezoids and as rectangles. So we go back to the paper. We could have done, we could have broken it into two rectangles, and we get the same area. All right, so now it says, how much will Alice pay if carpet costs $4.50 per square foot? Well, that calculation is $4.50 times the amount of square feet, 112.5. And so again, if you want to use a calculator on this calculation, you may. And my calculator is showing $506.25. I hope that is what you got. Okay? All right, let's keep going. I want to look at number 7. I'm going to fold my paper over so we can see it a little bit better. All right, here we have a picture of a backyard. And it says this is Hal's backyard. It has a patio, a walkway, and a garden. It also has some lawn, if you can see. And it wants to know about, first of all, what does that word tell you? About means we're estimating. We're not giving a precise answer, but we're still going to look at it mathematically. About what percent of the total area of Hal's backyard is the area taken up by the patio, walkway, and garden, round to the nearest whole percent. So we need to calculate the area of the patio, the walkway, and the garden, and we're going to figure out what percent that is of the whole yard. Okay, so maybe we start with the whole. We need to find out what the total base length is here versus the height and calculate the total area. So if we know it's 8 from here to here and 9 from here to here, then we know the total is 17 feet in length. We'll call that the base. And then for the height, we know it's 3 from here to here. And this height is going to be the same as this height. If you just slid it over, it would be the same. So it means it's 8 feet in height if we're looking downward on this, because again, this is a top-down view. So the total area would be 17 by 8. 17 times 8 is 136 square feet. So I'm going to just write that down here because we're going to calculate out of 136 square feet. That is our whole 136. We're trying to find the part that the patio, walkway, and garden are of that whole of 136. So now let's figure out what the area of each part is. The patio, we know this height is 5, and we can see this length here is the same as the lawn length of 8. So 5 by 8 would make that 40 square feet of patio. So I'm just going to write 40 inside the box there. The walkway is a little trickier. We know it's 9 from here to here. And we know it's 6 from here to here. So that means this missing piece would have to be the difference between them. That would make that 3 feet. So now we know that it has this base length of 3. The height we had already said was 8. So 3 by 8 is 24. So 24 square feet of walkway. And then for the garden, we see that this height is 3, and this is only part of the 9. It's 6 in length here, so 6 by 3 is 18. So now we have the areas for the 3 sections that we're considering. 40 plus 24 plus 18 gives us 82. So 82 is the part that we're considering out of 136. So if you do that calculation, 82 out of 136, this is what your calculator should show you. But it said to round to the nearest whole percent. So if you remember, the word percent means per hundredths. So if we look at just the hundredths, and we don't need to round up, you can see that it's 60 hundredths, which would be 60%. Okay? So I'm going to stop there. I'm going to ask you to finish part B and number 8. And I think that hopefully this was a good start for you. And if you have any questions, let me know. I'd like to see this page uploaded to Google Classroom when you are done. All right. Thanks, guys. Talk to you later.